This video demonstrates the Malviz, an interactive visualization tool for tracing malware. The dataset for our project was retrieved from the zoo, a malware database repository for research. We randomly picked 4 malware for our experiment. The Malviz malware. The ransomware server. The ransomware WannaCry. And the NJRAT. The process monitor application was used to capture the window log events. These events are filtered by operations including process create, load image, create file, write file, set rename information file, registry create key, registry delete value, registry delete key, UDP send, UDP receive, TCP connect, TCP send, TCP receive. The log events were filtered out by 13 operations. After putting the filter for the log events, we were going to run the malware and capture its operations. The ransomware server was selected first in our experiment. This screen was showed after the ransomware was run. The log events were exported to a CSV file with filter. This CSV file contains 6 features, including time of day, process name, process ID, operation, path and detail. First, all users were trained by using the Malviz with normal operation. 13 operations were listed as a legend in the middle and color encoded. These operations were grouped into 4 categories based on their type of activities. Operations related to file activities are encoded in orange color. Process activities are encoded in blue color. Network activities are encoded in red color. And registry activities are encoded in green color. The box on the right panel shows all the connecting domains that the log events recorded. And in the middle is the main or detail panel. The time axis is aligned horizontally from left to right. Each operation is represented by a thin vertical bar at its timestamp and color encoded based on its operation. When a process creates another process, an arc is used to show this relationship. When a user mouses over each process, a tooltip is pop up to assist users with detail information. The bottom section is the supporting panel. Data is organized into 2-dimensional array matrix. The vertical axis represents the processes, and the horizontal axis represents the libraries called. Each value in the cell represents the number of time a library is called by a process. This value is color encoded from white, 0, to black, biggest value. When user mouses over a cell, a tooltip will show detail information such as the number of times a library is called, and its timestamp. User can also filter out the matrix by moving the slider bar on top, or sorting the matrix to find interesting pattern through a selection box. This matrix can be sorted by name, by frequency, by different libraries called. And by the similarity. In the first study, users will experiment the behavior of the ransomware server. This malware involves connecting to malicious websites and encrypting files on local computer. We expect to reveal some of its behaviors. The connecting domains box shows that there are 332 domains captured by the log events. Some of them are categorized as malicious domains by VirusTotal. These malicious domains are encoded in red color for easy detection. The detail information of these domains can also be found in the detail panel when user mouses over an operation. For quickly detection for these malicious domains, the bar is set to higher than the others. This domain classification was retrieved from the VirusTotal API. We used Virus Total API to get the result. The response result was aggregated. The parent-child relationship visualization shows us that the Cerebro ransomware created another 4 processes in a chain within short time. This abnormal behavior does not shown in another process. The supporting panel shows us that this malware also calls too many different libraries. Sorting out the matrix also reveals this pattern. User can filter out the detail panel by selecting one of the bars on the operation categories. The second study was conducted by running 3 malware, which includes NJRAT, Kelihus, and WannaCry. We can see a lot of interesting patterns now. Topological ordering helps us see actions in sequence. For example, what time we run the first, second, and third malware. In general, all 3 malware performed a series of actions in short time as indicated by the alignment of the arcs. However, each malware has different behaviors. The first one only performed only a few operations, while the second one has more work and creates more processes in chain. The third malware shows the most activities, it keeps its operations in a longer time, and also creates another processes in chain. Other processes do not show this behavior. As the number of malware increases, the supporting panel contains a bunch of data. By filtering and sorting out the matrix, we can see some useful information and pattern. For examples, the WannaCry malware calls to a lot of libraries. Thank you for watching.